So to get started with the graphing of sine, cosine, tangent, and essentially all of the trig functions, I want to think about first how we've been working with them so far. So we know we put an angle around our unit circle, so let's just use, for example, pi over 6. We can get the trig functions of pi over 6 by recalling our common ratios for your 30, 60, 90 and your 45, 45, 90 triangles. Of course, pi over 6 is 30. So when you do those ratios, remember, pi over 6 is the smaller angle, so across the smaller angle is 1, hypotenuse 2, radical 3. And then from there I can say, oh, sine of pi over 6 is 1/2. Well, if we were to continue that around the entire unit circle using our quadrant angles, we can get an entire list of sine functions. Now let's talk for a minute about what the unit circle is. In the unit circle you have an x-axis, right, and your y-axis. And the point on the actual circle represents y being cosine, of course, x being cosine and y being sine. And that is if we were to, so that point, if we were to bring this down to 1, that down to 1/2, and that to square root of 3 over 2, just using proportional triangles, we have the point square root of 3 over 2, 1/2. So there again, our sine is 1/2, and our cosine is square root of 3 over 2. And what we learned is we can do this for all of our triangles. So for example, we can also use our quadrant angles. So we know sine of 0 radians. Well, 0 radians is going to be along the x-axis. Sine represents the y value, and the y value, of course, is 0. 0. We just said sine of pi over 6 is 1/2. And I'm not going to go through an example for each one. You can look at your notes from last. We know now that sine of pi over 4 is square root of 2 over 2 rationalized. Sine of pi over 3 is going to be square root of 3 over 2. Sine of pi over 2, which of course is going to here. Remember, that is the point 0, 1. Sine is the y value. So that's 1. And you can continue around. I'm going to jump ahead to just the quadrant angles and take sine of pi, which is over here, which equals 0. And then sine of 3 pi over 2, which, do that one in blue, takes us to here. And that, of course, is the point 0, -1. So that sine is -1. And then if we were to return back to sine of 2 pi, which of course is the same as sine of 0 radians, that brings us back to 0. So we have used our idea of the unit circle to actually get the values of sine of various angles. But now I want to graph sine as a function. So what does that mean? Well, normally write functions of f of x equals sine x. Or you can write it this way, y equals sine x. So we're not just getting ratios as we were before, we're thinking of this now as a function. Well, when I think of it as a function, I have to now think of it as an independent and a dependent variable, where my x-axis is now my independent variable, and my y is my dependent variable. Well, the independent variable is what you're plugging into the function. In this case, what we are plugging in to our functions is our actual angle degrees. So our x-axis are actually our angles. Well, what angles did we do so far? We went from 0 out to 2 pi. So of course 0 is here. So I'm going to put some of these angles in here. I'm not going to put them all. We can get an idea where the rest of them are. I'm going to put pi over 2. I'm going to use pi, 3 pi over 2, and 2 pi. And I'm going to graph the dependent variable, what the result is. So meaning sine of 0 is 0. Well, that's going to give me, I'll do this in green, point right there. Notice pi over 3 is a half, pi over 4 is square root of 2 over 2, pi over 3, sorry, that was pi over 6, is square root of 3 over 2. And then when you get to pi over 2, it has a value of 1. So it's up here. And so it's going to kind of gradually get there. All right, and then it's going to come down to pi. Sine of pi goes back to 0. Sine of 3 pi is down here at -1. 2 pi at 0 again. And you're going to kind of have that same pattern if I were to fill in all the other angles that we know. Okay, I'm going to move that up a little bit to 1. And what we start to have here is what we call our sine function. Now, we know that you can keep going around the unit circle infinitely in both directions, which means we can continue in this direction, go down, and then it's going to loop and come back up, and it's going to keep going. All right, so, and it's mirrored. We also know that sine is an odd function, so if sine of pi over 2 is +1, sine of negative pi over 2 is -1. Sine of pi is 0, 0. There is no negative and positive 0. And this function is going to continue. But if you take a look what I have highlighted here, this is what we consider one cycle of our sine function. And then we put the little arrows down there. So one complete cycle of a sine function is always going to start at 0 and end at 0. All right, but it will, sorry, always continue in both directions, so you got to be really careful. And we can do the same thing with our cosine function. Our cosine function, all right, very similar to sine, but if you think back to your unit circle, all right, and think of those quadrant angles around it, when you take cosine of 0, remember, it's the x value, so cosine of 0 is 1. And then if you recall, using your common ratios, cosine of pi over 6 is now going to use the adjacent side of what we drew up here, so it's going to be square root of 3 over 2. And then cosine of pi over 4, well, that happens to be the same thing as sine because they are isosceles right triangles, so square root of 2 over 2. And then cosine of pi over 3 is going to be 1/2. So now think about what cosine of pi over 2 is. Cosine of pi over 2, well, you got to go up here. That's the point 0, 1, so that goes to 0. And then we'll just hit the quadrant angles. Cosine of pi, of course, goes down to -1 because that's the x value. Cosine of 3 pi over 2, my negative y-axis, brings that back to 0. And of course, cosine of 2 pi is going to be exactly the same as cosine of 0, and that is a 1. So, doing the same thing we did with our sine function, let's draw a sketch of our cosine function. And for your cosine function, We need the same angles, but again, I'm just going to put the quadrant angles in there. So we have pi over 2, pi, 3 pi over 2, 2 pi. Now, well, cosine starts at 1, hits 0, goes down to -1, 1, 0. Here is what one cycle of our cosine graph looks like, but that is only a cycle. The cosine graph itself, cosine being an even function, negative pi over 2 is going to be exactly the same thing as pi over 2. And then it's going to continue. And it's going to be actually perfectly symmetric around the y-axis because it is an even function. But once again, one cycle, we picture it, kind of looks like this. We talk about one cycle there. All right, so that is our cosine function. All right, you have your sine, your cosine. Let's take a look at tan. Well, actually, we'll save tan for the next video. Let's just focus on our sine and cosine for now. So I wanted you first to understand the relationship between when we get trig functions off of a unit circle, when we get those ratios, but when we transform them into a function and graph your independent versus your dependent variable, this is where you get your sine and cosine curves. This, of course, being f of x equaling cosine x, or you can think of it as y equals cosine x. These are the standard functions. Now, just like you did in pre-calc 1, when you took standard functions such as x squared, square root of x, 1 over x, you were able to do transformations of those functions. Move them up, move them down, squish them, stretch them, all that other fun stuff. We're going to do the same thing with our trig functions. So to do that, you're not just going to graph cosine x and sine x. I'm going to make them a little bit more interesting. So let me give you the standard form of both our sine and our cosine function, because there's a lot of different kind of things we can do to these. They can shift, they can stretch, they can shrink, everything else. So for example, y equaling a can be multiplied, the x can be multiplied, we can subtract from the variable itself, and I'm going to even add a piece here called plus d. We're not going to work with that too much, but I at least want to explain it to you what it is. And cosine would look exactly the same. Ex minus c plus d. The difference between the two when you're graphing them in is how you begin. The same as the difference between if you're doing a transformation of y equals x squared versus y equals square root of x. Here, if you're doing a sine graph, you're going to start with thinking of one cycle, beginning at 0, going to 1, hitting 0, going to the minimum, and then going back to 0. If you're doing a cycle of your cosine graph, you want to think a cycle is going to start at the highest max value, in this case 1, but that could be something different. Hit 0 over pi over 2, then it hits its min value, then it hits its intercept, and then it hits its max. So think of it this way. Your cosine graph goes max, intercept, min, intercept, max. Hitting those 5 points will get you one complete cycle. And then, of course, you can just do the arrows to continue. Sine graph's a little different. Sine graph starts intercept, max, intercept, min, minimum value, and intercept. So knowing how a sine graph kind of is formed and how your cosine graph's formed will really help you as we start to make changes to these max and these intercepts and these minimum values. All right, so what does each of these represent? So for both your sine and your cosine graph, A is simply what we call amplitude. Actually, absolute value of A. Sorry, let me preface that. Absolute value of A is our amplitude. The amplitude, well, let's put it this way. Twice the amplitude would be your distance. So if you have a basic curve, right? The distance from here, to here is A. So the distance from the max completely to the min itself is 2A. All right? So as long as your graph does not have any sort of vertical shift up and down, your amplitude is the distance from the x-axis to the max and the min. Okay? And that goes for both of them. Now, the next thing we want to talk about is the period of your graph. Well, we have already learned that the basic y equals sine x and y equals cosine x. Take a look at the graphs. Period means how far from the start of a cycle to the end of a cycle. All right, so when we talk about period, talking about this distance. Start of cycle to end of cycle. So for the cosine graph, I'm looking at max to the next max. And for a sine graph, I'm looking intercept to the second intercept. We'll give you one complete period. Both of those graphs, both sine and cosine, have a period of 2 pi. But we're going to adjust that period, and we're going to sketch graphs that don't necessarily have a period of 2 pi. So, how do we determine that? Well, simply take 2 pi, divide by b, we'll get your function, your sine and cosine graphs, period. So to start with 2 pi, because that's the general graph, has a period of 2 pi, and simply divide by b. That will tell you how far a distance from the beginning of your cycle to the end of your cycle. The next thing is shifting it. The phase shift is what you would know as your horizontal shift. So when we talk about a phase shift, you're thinking of it as the initial point of that cycle. Where is it shifting to? So right now, the initial value of your sine graph is at 0, 0 for one cycle. Here, for this cosine graph, we are at 0, 1 for one cycle. We're going to shift that horizontally. This is your phase shift. Phase shift is simply determined by taking C over B. Now I want you to be very careful. The original functions, whoops, not what I wanted to hit. Have a negative there. All right, so your phase shift of C over B is a phase shift to the right. But if your function looks like this, you need to rewrite it and essentially your phase shift becomes negative c over b and goes to the left. And you may recall this with transformations of other functions. When you had a plus, you actually went to the left. And when you have a negative, you actually go phase shift to the left. This will essentially give you your starting value of one cycle. So that's going to be a pretty important piece of information. Now, again, I'm going to write vertical shift. We are not going to deal too much with vertical shifts. Vertical shift is the D value, and all that simply does is shift your graph up or down D points, whatever D happens to be. So your vertical shift is simply the D value. Positive D, your graph shifts up. Negative D, your graph shifts down. And is no longer centered right on that x-axis. All right, so what does all this mean and how do we use all this? So here's a recommendation I have for you. Take a minute and get on Desmos and kind of play around. So here's my recommendation to help you understand all this. On Desmos, start by sketching a graph of y equals sine x. Then simply make single adjustments. In other words, try y equals 3 sine x and take note of what it does to your graph. Try y, remove the 3 now, of 2x and take note of what that does to your graph. In other words, just change one of these values, a, b, c, to see how it impacts your graph. And then I would go ahead and do y equals sine of 1/2 x. Then y equals sine, and make sure you use parentheses on this one, x minus pi, do a phase shift to pi, and then change that to y equals sine x plus pi. Put it all together. 2x minus pi over 2. What does that do to your graph? Make it positive. Okay? This is where you need to explore to look at different ways that changing the ABC values will change your graph. The best way for you to do that is kind of explore on your own in Desmos. So what we're going to do is go ahead and let's do it algebraically now that you've seen it in Desmos. Or if you haven't, let's do it first algebraically, and then we will check it in Desmos. So we're going to go ahead and graph the function y equals sine 2x minus pi over 2. So something I want you to recall from earlier in the video. Couple things. Number one, do note that this is a positive sine function. We'll talk about what happens if we stick a negative in front of it in a minute. So, your positive sine, recall that y equals sine x simply goes looks like this, one cycle of it. We only need one cycle. So we're looking at an intercept, a max, an intercept, a min, and an intercept. If you can come up with those 5 key points, you have your graph. And that's what we're going to work on. We're going to work on how do I get those 5 key points. All right? So notice we're doing a positive. Let me make one note about negative functions. Negative functions reflect over the x-axis. So a negative function would simply reverse everything. Well, your intercepts do not change I. What changes is your min and max value. So while you were playing in Desmos, go back and take any of those graphs and just simply put a negative sign out front. Change your A value to a negative. All that does is the distance between the max and the min remains the same. So technically the amplitude does not change, but the direction the graph starts does change. Keep that in mind. All right? But we don't need to do negative now. We're going to do a positive graph. So here's how I go about doing it. First, I state my amplitude. Well, that's just 1, so that doesn't adjust anything. Absolute value, technically absolute value of 1 is 1. It's good. The next thing I'm going to determine is the period. Well, remember, sine graph has a normal period of 2 pi. So the period, you've stated up here, is simply 2 pi divided by b. So in this case, it's 2 pi divided by b, which is 2. There's your b. I have a period of pi. What does that tell me? That tells me when I start with my initial part of my cycle to the end part of my cycle, there's only going to be a distance of pi between those values. Phase shift. So phase shift, we said, is c over b. Keeping in mind, the original function is negative, so the negative does not impact it. C is pi over 2 divided by 2. Pi over 2 divided by 2 is pi over 2 times 1/2, so it becomes pi over 4. Think of this as your starting point. So what do I mean by that? Well, to draw a sine graph, I need 5 values. I start, and remember, this is just one cycle. One cycle. It starts with an intercept. It goes to a max, then an intercept, then a minimum value, and then an intercept. Now, there's 5 points, but there's 1, 2, 3, 4 areas in between those 5 points. So you got the distance between here, 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 and here. So if you take your period and divide by 4, you will get, we call the distance between key points. The distance between your key points. All right. Well, let's start with my first key point. I am no longer starting at 0, so go back to your original sine function. Your first initial point is 0, 0, but I'm not at 0 on my x. I have to adjust it due to the phase shift. So I'm starting at pi over 4. Do note, we did not change the amplitude of this graph. It is still a x-intercept, so the y value is 0. All the intercepts are going to have a y value of 0. Don't forget that. In fact, you can fill in your y values because your max, you have an amplitude of 1 is 1, and your minimum is -1. So those values are pretty straightforward. Now, we said the distance between also happens to be, just on this one, it's not always going to be equal, pi over 4. So what does that mean? Well, to get this value here, I take my pi over 4 from above and add another pi over 4. Well, that's going to give me 2 pi over 4, which is pi over 2. Okay? To get this value, I take that pi over 2, and again, add pi over 4, because we said that's the distance between each point. So you've probably started to get pretty good at adding these fractions together. Pi over 2, of course, is 2 pi over 4, so that's going to give me 3 pi over 4. Again, from 3 pi over 4, add another pi over 4. 4 pi over 4, which of course is simply pi. And for the last point, we'll take our 4 pi over 4, add another pi over 4, and I get 5 pi over 4. Now, you can check yourself. This is the beginning of my cycle. This is my end of my cycle. The cycle period is pi over 4. The cycle period is pi. Well, here's how I can check. Pi over 4 plus pi should equal 5 pi over 4. And it does. So now, I can simply draw it out. I need to put pi over 4 on my graph. I need a pi over 2. I need a 3 pi over 4. I need a pi and a 5 pi over 4. And my graph is simply and then 1, negative 1. You can draw your cycle, but don't forget to put those arrows in because we know it continues infinitely in both directions. I'm going to stop this video here. In the next video, we'll just throw in a couple examples.